Hello everyone. This lesson we're going to talk about three-phase system. In three-phase, we have two different kind of system. One called a Y system, another one called delta system. We connect three leads to a common point. We build a neutral point in the center. If we connect the three leads this way, we build a three-phase Y system. This could be the supply or source, or this could be the load. If we connect the three-phase, each to two ends of the winding together, then we have a delta system. Delta looks like a triangle, and that's where you get the name called the delta. So we have the Y system and the delta system. We're going to talk about Y system first. In three-phase, we have the voltage phasor, we have the current phasor. The voltage phasor, like we talking before, is open-ended. The current phasor is closed-ended. We know the source is going to supply the voltage. The load going to decide the current. In this case, this phasor diagram I'm showing you is a purely resistive balanced load. We will cover more down the road, tell you what's resistive load, what's balanced load. But you can see the three voltage, they are 120 degrees apart. We start with phase A, then phase B, and phase C. The current, when they are in phase with the voltage, that's where I mentioned purely resistive. Three current, phase A, phase B, and the phase C. They are also 120 degrees apart. Now let's look at more detail into the Y system. A Y system, if phase A from the neutral or the common point, we have 120 volt at 0 degree. And the phase B, we also have 120 volt at 240 degree. Phase C, the same voltage, 120 volt, 120 degree. So this phasing is rotating counterclockwise. Phase A first, phase B next, phase C, the last one. We do the vector subtraction because we know voltage. If I try to measure voltage between line A and the line C, voltage is called potential difference. So when we try to find that voltage, we're going to use one phase voltage subtract another phase voltage, as we did in the vector subtraction. We gave us 208 volts. So in Y system, when we have phase voltage is 120 volts, the line voltage is going to be 208 volts. How can we find that number? We can use the phasor or vector subtraction to find that, or there's a famous triangle in three-phase system. It's a 30-degree triangle. The hypotenuse is going to be 1. The opposite side is going to be half of the hypotenuse. And the adjacent one is going to be just 2/3 of that hypotenuse. We have a three-phase voltage from a neutral or common point to A, B, C. Then we have three line voltage between A and the B, between B and the C, between C and the A. So that's the relation between phase voltage and the line voltage. If we're using trigonometry to solve it, we have two phase values at 120 degrees apart. And the hypotenuse is going to be our line voltage. We divide that phase voltage into two, Each side we have 60 degree. Then this is a right angle triangle. We have 30 degree on that side, 30 degree on this side. Remember the triangle we just did? When we have hypotenuse is 1, at the 30 degree, the adjacent side is just going to be root 3 divided by 2. So in here, here's our phase voltage. Compared to the diagram before, this is going to be 1, this is going to be 1. Each half of our line voltage is going to be root 3 divided by 2. Now we have 2 of them, we add them up. So now your line voltage is going to be root 3 higher than your phase voltage. So here's the important rule for you to know for your 3-phase Y system. For a Y system, your line voltage in Y system, the line voltage is going to equal to root 3 of your phase voltage. Looking back on this drawing here, if I have a current came out from this phase, this phase and the line, they connect directly together. So your phase current is equal to your line current, which you can see in this drawing down here. Here's my phase current from the neutral to point A. That's my A phase current. When this current go to the low, there is only one path for this current to go to the low. So this path in the center is the line. In here, I only have one path. My source, my line, and my low is connected in a series circuit. Series circuit, current will be the same. So the current relation in a Y system will be line current equal to the phase current. So we're just going to cover the Y system up to here. If you have a question, or next lesson, we're going to cover the delta system.